Can you hear me?
Yes. The connection is good, I think. Okay, we will start in few minutes.
Okay. Yeah, actually, as I mentioned you earlier, when I touch my mouse, the camera is getting turned off. I don't know why.
Ah,
So
really?
hopefully it will stay. If not, just please excuse me. Okay.
Okay, no problem.
Okay.
Okay, we're still waiting for our head of department.
So yeah, I can share my screen.
Yes. Maybe you can try to share your screen. Okay. Could you make it a slideshow?
Okay. So do you want me to start?
No, not yet. I will open
Okay.
first.
Sure.
Okay, I think we can see your screen. No problem, I think. Yeah. Good. Wait, I will try to call my head of department.
I don't know. Mm.
Okay. He didn't reply. Maybe he's on the way somewhere. Okay, maybe we could start. So I will open first. Could you?
If you want, we can wait another couple of minutes.
Yeah. Could you stop the share screen first?
Okay.
Before. Okay. Okay. So I'm sorry to disturb you at night.
No, it's fine. You see?
If you touch your mouse, your
Yeah.
camera will turn
I don't
off.
know. Maybe because this is a gaming computer, I don't know, something happened. Yeah.
Yes.
And actually, I had lecture today, so I had to drive like 100 miles to away. So anyway.
Okay. I think we should start on time. So maybe later, if our head of department join us, maybe he will say something for the closing of the meeting. Okay. Hello, everyone. Good morning. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Very good morning to all of you. We will have today we will have international guest lecture on a very interesting topic. This low cost precision agriculture will be delivered by Dr. Abdul Momin. And he is from Arkansas University at Pine Bluff. Maybe before we start the lecture, I would like to introduce the speaker. I'm sorry. So here's the short CV of the speaker, Dr. Muhammad Abdul Momin. He's assistant professor in agricultural engineering, University of Arkansas at Pine Bluff, Arkansas, USA. And he got his bachelor degree and master degree from Bangladesh Agricultural University and PhD in agricultural science from Kyoto University. He got a lot of experience in other universities than Bangladesh and also in Japan, including University of West Indies, Trinidad and Tobago as temporary assistant lecturer, and also University of Illinois at Urbana-Champaign, Illinois, USA, University of California, Davis at California, USA, and Department of Healthcare Services, Sacramento, California. And also now currently he is now in University of Arkansas at Pine Bluff as assistant professor. He got a lot of experience in teaching and also a lot of publication. And we're really looking forward for knowledge that he will deliver from on the today guest lecture. I would like to inform Dr. Momin that we currently have many participants. Most of them is students from Bachelor of Engineering, of Agricultural Engineering, and also there are students from Bioprocess Engineering, and also we have some colleagues from Kyoto University, from IPB, and from several other universities in Indonesia, and that joining us, and also some from industries. So before we start, we have our head of department here, Dr. Adi. I hope you could open the guest lecture.
Okay.
Time and place is yours.
Okay. Thank you very much, Dr. Dimas. Good morning and good evening in United States. Okay.
Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I would like to open this guest lecture. Thank you very much. I very grateful to hear that Dr. Abdul Momin can join with us, and as a head department, we look forward to have other collaboration, because in right now we need it's kind of the collaboration and internationalization. We have some colleagues that have a specialty almost the same and have connected with our colleagues in abroad. That's why, like Dr. Dimas, and we have also Dr. Yusuf Hendrawan, we have the specialty as smart farming and as we call precision agriculture. And in this case, it is the first step for us to invite you as a speaker, and we hope we can collaborate both in research and also in our teaching process. And now we invite Dr. Abdul Momin as a teacher, and we hope we also have a 3-in-1 program, and we collaborate between the academia from abroad and also the industria in Indonesia, and also in our internal teacher, in our internal lecturer. So between the 3 speakers, we can combine and we can enhance the competence of our student to reach the to enrich their competence in their future, I hope. So in this case, I would like to say thank you again, and we hope our collaboration is will continues, and also the condition in Indonesia is right now, we don't have sophisticated technology. So this topic is very relevant with our condition, because in our culture, and also we have resources, but also we have a limited high technology. So in the case of low cost precision agriculture, it's a very beneficial for us. I think we need to continue our collaboration, not only with the teaching and also with the research and also community services, to give our community, especially in Indonesia, to increase their welfare. Thank you very much to Dr. Dimas and Dr. Abdul Momin. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Adi, for the opening speech. I would like also to welcome to some of our colleagues from IPB University, including Dr. Slamet. Maybe Dr. Abdul Momin know very well Dr. Slamet. You can say hi, Dr. Slamet.
Okay, thank you very much, Dr. Dimas. I think it's very great pleasure for me to join this meeting, so we can meet old friend, this Dr. Momin. I think it will be very interesting topics, and I think a lot of experience that he gained from maybe because a long time in the US, maybe we also get some update in our field, especially maybe, of course, maybe we already quite long time. I think we joined in the Kyoto, I think almost 10 years ago, right?
Yeah.
So I think it's many things I think that maybe Dr. Momin we can share, and again we can also.
Actually, I am feeling shy now presenting in front of you, because, Dr. Slamet was one of my best friend and one of my best mentor when when I did a study at Kyoto University. So I learned a lot of things, especially how to design a good presentation slide.
Okay,
Yeah,
thank
we
you.
have a lot of memories.
Thank you, Dr. Slamet, for welcoming also Dr. Momin. Okay, I think we could start now. Dr. Momin, you could share your screen, and time and place is yours from now, maybe around 50 minutes to 1 hour presentation, or up to you, and then we can continue with discussion.
Okay. I hope you guys can see my slides.
Yes.
Okay.
You can see.
Yeah, again, Assalamu alaikum, everyone. Happy Friday. And, first of all, I would like to thank Dr. Dimas, and as well as Dr. Adi Sulianto, and finally, University of Brawijaya, for giving this guest lecture opportunity to talk about low-cost precision ag in front of these beautiful audiences, the next generation problem solvers. My name is Abdul Momin. I recently joined as assistant professor in ag engineering at University of Arkansas Pine Bluff. Let me briefly talk about this program at UAPB. This is a fairly new program. They just opened this program last year fall. So it's a big challenge for us to run this program, to get the accreditation approval. So I think this is a very good opportunity for me as well as for my department, because we are also looking for international collaborators in the future. So that's why, thank you, Dr. Dimas. And when you approached me for this guest lecture, actually, I did not hesitate to take this opportunity. Thank you. Okay. Next. Okay, in this slide, I am a little bit selfish. I showed some of my pictures throughout the US and Japan where I work in the field. So in today's presentation, I'll talk briefly about myself, and then focus some of the key challenges as agricultural engineering we are facing right now, and our research motivation, why we are thinking about low-cost precision ag. And I'll discuss about two of the feasibility studies we did recently. Okay, so I am originally from Bangladesh, a beautiful small country located in Southeast Asia. Though Bangladesh is a small country, it has huge population with 165 million people living in an area roughly the size of Iowa state of USA. So think about how much we are living, population density, how high the density of population is in Bangladesh, like about 3,000 per square mile, where in Iowa, only 56 people per square mile living. On top of that, currently we are now sheltered more than 1 million Rohingya refugees from Myanmar. So we are proud of these two gentlemen, Professor late Sheikh Mujibur Rahman, the father of the nation, the prime architect of the independent Bangladesh, and Professor Muhammad Yunus, the Nobel Peace Laureate, the pioneer of the microfinance and microcredit concepts. We have seasonal diversity, and the 6 seasons provide excellent agricultural activity and abundance in total production. As Dr. Dimas mentioned, I did my bachelor and master's in agricultural engineering from Bangladesh Agriculture University. And I did my PhD from Kyoto University, Japan in March 2013. Since completing my Bachelor of Science, I have continued to pursue teaching and research in different capacities and institutions. I work as a postdoctoral researcher at North Dakota State University, University of Illinois, and University of California, Davis. And also I got experience to work as a research specialist in the public health department in California before joined at UAPB. And my current areas of research focused on agricultural mechanization, precision post-harvest engineering, precision ag. Okay, the increasing world food demand and changes in the climatic conditions are current key challenges facing by the global agri-food sector. We all know that for population and income are two big drivers for food demand, and they both are growing up. The world population expected to rise over 9 billion in 2050. So the growing world population will directly impact the resources of food and agricultural production, as well as the food loss and waste throughout the world increases, which is another key factor. So it is estimated that about 1.3 billion tons of food is lost or wasted annually. Among them, like 600, if we split that amount, 630 million tons per year from the developing countries and 670 million tons per year from the developed countries. If you see the drivers, we identified these drivers associated for food loss and waste, even though the drivers, a lot of drivers affected the food loss or waste in developing countries, but in terms of amount, quantity, still the developed countries food lost happen higher than developing countries. Even in USA, if you notice, about 40 to 50% of total produce thrown away, which is equivalent to about 60 million ton of foods annually. And if you analyze, if you go further, you will notice that in food loss and waste in developing countries mainly happened before reaching to the consumer, before reaching to the table. And the main constraints or main drivers associated with food loss and waste, actually the lack of infrastructure facilities. For example, lack of drying facilities, lack of appropriate storage facilities. In contrast, if we see the drivers associated with food loss and waste in developed countries, is mainly the behavior or aspect from industry or supermarket or consumers. They sometimes by overbuying, they displayed large quantity of foods into the supermarket, and sometimes actually over purchased or overeating. So that means the predominant drivers is actually the human behavior and behavior and aspects associated with the food loss and waste in developed countries. So if you see go to the Bayer Crop Science Company, they recently organized this live poll on future of food and agriculture, where 66% people believe that yes, we can feed the growing world population with innovative solutions. That means by introducing digital ag, precision food engineering, field robotics, and conservation agriculture. So that means, from my understanding, the future of agriculture depends on the next generation of problem solvers, which means that we, the agricultural engineers, we are the next generation problem. We need to work as a next generation problem solvers. So now let me briefly talk about why we are focusing on the low-cost precision ag. The precision agriculture is an information and technology-based management system to identify, analyze, and manage site spatial and temporal variability within field conditions for optimum profitability, sustainability, and protection of the environment. By using precision agricultural technologies, we can generate data pertaining to agronomic data, soil data, crop protection data, or machine data to quantify the spatial variability of field conditions. And finally, we can generate the digital prescription or yield maps for location-specific cultural practices. So, for example, for fine-tune adjustment, fine-tune nutrient adjustment, or to identify the low and high yield zones of the field. Studies in USA, studies found that by using precision agricultural technologies, USA farmers can increase yield by about 2%. They can reduce energy cost from $7 to $13 per acre. Also, more importantly, they can drop the amount of irrigation water used by 8%. So the precision agriculture mainly comprises the technologies including global positioning system, GIS, geographic information system, remote sensing, variable rate technology. However, to expand the adoption of precision agricultural technologies, mainly to the small farm or to the minority farmers, or as well as to the small scale farmers in the developing countries, it is necessary to bring down the capital cost of the related technologies. We notice that one of the thing we can handle, like the GPS, this technology has been seen widely used in field robotics and agriculture. So there is an opportunity to reduce the cost of this technology. So that's why in our research, we focused on to use low-cost GPS technology for developing yield map, for developing prescription map, or vehicle guidance purpose. So as all we know that yield map is an important component for precision agricultural practices and assessing field spatial variability. And so far, yield map can be produced by using a yield monitor embedded in the harvester or by analyzing remotely sensed imagery. A drawback of the machine embedded yield real-time yield monitor system is their dependency on frequent calibration and maintenance as well. However, yield map from remotely sent imagery, on the other hand, can be inexpensive and easy to produce compared to the machine embedded yield monitor. However, here they are at block or farm level, and their accuracy and adoption rate is too low, it's still at industry or research level. So the sugarcane, if you see in USA actually 5 states there are farmers growing sugarcane, mostly in Louisiana and Texas and Florida, Hawaii, and some part of Iowa. So if you go to the visit those farms, you will see the sugarcane yield monitors developed so far are for research purposes. John Deere working in depth on this area. Few are available commercially, but the adoption is low, mainly because of lack of accuracy. So that's why we're thinking to develop a yield mapping system based on GPS tracking of vehicles. Or the logic we use to develop the yield map, I would like to run this video to show to the students actually for their easy understanding. This video actually we captured using a drone during our field experiment at Louisiana. So I hope, can you able to see the video?
Unfortunately, we cannot see.
Okay, let me share the presentation and share my screen, entire screen. This one. I believe now you can see.
Yes.
Okay. So this is our field where we run our low-cost GPS. And this is the combine harvester we used for experiment. And if you see in sugarcane harvesting process, all machines interact each other. And if you see here, the harvester harvesting, and then one wagon, one tractor with wagon actually following, and another is filling. So there are 2 different machines here. One is filling tractor, another is following. So to reduce the time, because harvester has little onboard storage and must continuously unload material into the wagon. So once a wagon is filled, the tractor operator drives to a transloading site to unload into a semi-truck. You see this wagon is filled, so this tractor is going to the unloading transloading site where a big semi-truck is waiting, and the following tractor comes to the harvester, and then unloading start, harvesting and unloading start. So this is and if you see, based on this mechanism, actually we developed the yield map. So if we go a little bit further, now you see the tractor leaving the road during the turning operation. You see first tractor leaving the row and then heading up the headland. Harvester going to complete 180-degree rotation, and then rotation of the topper blades are reversed, and the elevator is rotated to the other side of the harvester. And now if you see here, look at this follower tractor and wagon is now came close to the harvester. So please remember this particular clip, this particular image. So in the next slide, I'll discuss about this, what is happening here for developing, what's the problem we faced for developing the yield map. Now, once the harvester now is ready to harvest, and the existing tractor is coming, trying to come here, and then harvest operation starts again. So let me close this video now. Okay, so to stop sharing while we are here. Okay. Okay, Okay, so to develop the yield map, what we did first, a GPS units used to log the movement of the harvester, tractor, and the semi-truck during harvest. And this GPS unit is cost, actually we bought from the Amazon. It's cost $100 each GPS unit. So we bought 10 GPS unit for this whole entire experiment. And the one disadvantage of this GPS unit is you need to operate your machine at least 6 kilometers per hour. So like I sent this device to my country, Bangladesh, but they were not able to log any data because of this speed limitation. So the mover will be at least 6 kilometers per hour. Otherwise, the GPS will not communicate with the satellite or whatever. This kind of limitations have. Is the main limitation of these GPS units. Anyway, for the yield map logic, we use 3 different steps. First, we identify all the field events and their interactive distance. How we did that? For each field event, the locations of the harvester and tractor were recorded. It was assumed that when both the harvester and tractor were traveling in parallel and the harvester was within a 10-meter radius, and the harvester, if you see here, if the harvester was within a 10-meter radius of the tractor for a prolonged duration, the harvester was filling the wagon. So the harvester will filling the wagon. So here is, this is the filling tractor and this is the follower tractor. So first we identify the location of the harvester and tractor, and then the harvester was within a 10-meter radius of the tractor for a prolonged duration. That particular time we considered the harvester was filling the wagon in the filling tractor. Okay, based on this condition, the interaction distance, that is the field event distance through which the harvester and tractor were traveled in parallel, were calculated for each specific tractor at a specific time. So we had we used for this inter-harvesting, there were 5 tractors. So for all of these tractors, we recorded the data. And then what happened, we had some difficulties during the turning. Like this is the clips or image or stationary image of that video clip. You see, when the turning, during the turning procedure, it was observed that a field event related to an existing wagon, this one, was interrupted. And the follower tractor, the tractor which was following this harvesting operation, the follower tractor ended up being closest to the harvester. You see, this follower tractor ended up being closest to the harvester here. So after completing, and this happened for a short period of time, after completing the turning procedure, the current tractor, this current tractor then resumed being the closest to the harvester. And the field event continued. So to manage such interruptions, how we manage this kind of interruptions, these short period interruptions, for measuring the field event of the existing tractor, a filter was applied based on average field event length and discarding the significantly shorter field event length. This shorter period of field event length we discarded because this happened only for a short period of time. So if we know the filling the field event distance to fill that wagon, then we use that threshold to discard this short period of time, travel time. So this is the simple flowchart of the yield map algorithm, where you can see the input. This is our GPS data, and the data we got in degree. So we need to transfer into meter in zone, because Louisiana is in zone 15N. So we transfer data into meter, and then we calculate the field event distance based on the logic, as long as the tractor and harvester travel in parallel within 10-meter radius, based on that logic, we identify all the field events. And once all field events and their corresponding distance were identified, a yield for each field event was determined using this equation. This is, we use the equation because here 1000 is the constant value, conversion factor, unit conversion factor. WC is the wagon capacity. For your information, none of those wagon has a weight sensor. So it is based on intuition that the farmers and the harvester operator, they knew when the harvester wagon got filled, and they are based on their intuition, the wagon capacity we consider as 10 ton for each wagon. And we know the field event distance that we calculated from our GPS data, and we know the row width is width of the each row. So then we can calculate yield. And finally, we develop the yield map. So if you see this data table, a total of 76 field events were identified for 5 tractors within a 7.1 hectare area. And the average length of distance traveled for each tractor was found to be approximately 515 meters. That means if a tractor and a harvester traveled in parallel about 515 meters, it's one field event. That means that particular distance actually required to filling a wagon. So that's the that is considered as one field event, and we found 76 field event for these 5 tractors. And if you see, more interesting is the total distance traveled and harvested area, total distance traveled and harvested area covered by each tractor was near uniform. That supporting the fact that the sugarcane fields in Louisiana are designed for controlled traffic, because they maintain the traffic very efficient way. So finally, if you see, this is step 1, the results of step 1, where you see the left figure is the field events of tractor 1. So there are 15, I think, for tractor 1 we have 15. So we have 15 field events here, and this is the combined field events of all 5 tractors. And then we transfer from the field event to the yield using that equation, and we get this is the yield of tractor 1 and yield of all 5 tractors. And then finally, to observe a yield consistency pattern, an interpolated map was created using inverse distance weighing interpolation method. And finally, a cluster map was developed from this interpolated map to classify sugarcane yield for the harvested field based on sugarcane production. So divided into high and low yield zones from this interpolated map. And this is summary. I think it's better to skip this. Like a total of 76 field events were identified for 5 tractors within a 7-hectare harvested area, and the generated yield map was divided into high and low yielding regions, and the maximum variation was observed approximately 10 megagram or 10 ton per hectare. So the variation was very minor, and we checked the data with the mill industry data, and almost they are tied, the numbers are tied. Okay, our next feasibility study we done actually for the guide to develop the guidance system, and we use 2 low-cost RTK GNSS. So what we did, so we know the various guidance systems are in use in field robots, like a GNSS-based guidance, machine-based guidance, and a LiDAR laser sensor-based guidance, or a combination of these. The field robot guidance based on GNSS uses RTK GPS that provides the centimeter level error in real time. RTK GNSS relies on wireless communication between a stationary base station and a rover, a mobile rover. Integration of a RTK GNSS in a robot or a machine increases its cost dramatically because as RTK GNSS can cost up to 20 to 30,000 US dollar. So therefore, if we want to widely proliferate the application of precision agriculture in general and agriculture robotics in particular, it is imperative that the cost of an RTK GNSS be reduced significantly. So, nowadays, low-cost, compact RTK GNSS modules are available that can be readily incorporated into robotic applications. Since open source libraries are available for RTK GNSS collection, and because system software can be executed on a small, low-cost computer boards such as BeagleBone Bluff or Raspberry Pi, the combination of all these elements may enable widespread utilization of low-cost RTK GNSS technology in agriculture and beyond. So in this study, the construction and configuration of two low-cost RTK, distinct low-cost RTK, single-frequency RTK GNSS, and the evaluation of their positioning precision and accuracy in a dynamic setting was studied. Each GNSS rover was mounted on a field robot that was traveling by manual remote control along a predefined test track in 6 repeated trials. And the combined accuracy of the two GNSS was determined by comparing the positioning data to a fixed known distance between the two GNSS antennas on the robot. Like these two GNSS antennas, we fixed this distance, like for the distance was between these two antennas 472 millimeter. And then we compared the positioning data with this fixed distance. So this is some our results, and for the 6 trials. Here, if you notice the 6 trials, among 6 in 4 out of 6 trials, both GNSS like trial 1, trial 3, trial 4, and trial 6, both GNSS remained in fixed solution status. Both GNSS like ER-RTK and NS-RTK. ER is IMLIT RTK and NS is Navier-Stokes RTK. If you see, both RTK actually in fixed solution status, and showed a root mean square error below 50 of less than 50 millimeter, which was within the expected range. Actually, for field robotics application, we are expecting like 0.5 to 1 centimeter error level. So it's within the expected range. However, in one trial, like one of the GNSS, if you see in number 2, one of the GNSS at the beginning started in float solution status. If you see, float solution status, and then it subsequently transitioned to fixed solution status. In this trial, the root mean square, because of this region, the root mean square error was still well within 1 meter. You see, 122. So within 1 meter, which was expected in float solution status. However, one interesting thing we noticed for in one trial, a false fixed position status was encountered. You see here, this GPS actually is not fixed, but it's showing it's in fixed position status. Where the Navier-Stokes, this is Navier-Stokes GNSS, this GNSS falsely claimed it was in fixed solution status. This issue needs to be actually elevated in the future by improvements in signal conditioning, noise, and software, and or by using sensor fusion. So when we combined all this data, we figured out that the IMLIT GNSS had superior localization performance because it produced about 94% data in fixed solution status compared to Navier-Spark GNSS. It produced about only 70% data in fixed solution status throughout the trials. So, however, both the data showed that both tested low-cost RTK GNSS have potential for use in experimental guidance system in agriculture and beyond. So our current research, actually, we are now working on tracking and monitoring harvesting machinery performance in real time using the low-cost GPS technology, as well as we are also using vision-based, like $40, $50 web camera. Also, in parallel of this GPS tracking device, we are using that low-cost camera to collect the images, also the video in parallel with GPS tracking device. So using those data, actually, we are trying to manage the idle time to improve the machine productivity. Because in USA, actually, we've figured out that about 30% of the total operation time, actually, the machines consume the idle time. So 30% of their total operation time. So it's a huge. So to manage the idle time and also cutting cost associated with harvest disruption and also quality harvested produce, like the less smart forest debris, those kind of things by using the camera, and analyze overall logistics and machine productivity. And also our second approach is like vehicle tracking. So we are now thinking to check to apply that yield pattern technology for soybean field, and also for developing a prescription map for input management. So, but these are all in ongoing stage. And our team actually splitted because one of my partner, he is now in Brazil, and another partner in Illinois. So I am at Arkansas. So we stuck on our work. Hopefully, we are trying for a big fund. So once we get that, we'll resume our work. And that's all. Thank you for your attention. If you have any questions and suggestions, feel free to ask. And this is some of my memories from 2015, I believe, when I visited Bali to attend the spirit workshop. I think Dr. Widodo will be here, I believe. Oh, yeah, he's here in the middle. Okay, yeah, that's all.
Okay, thank you very much. Excellent presentation, Dr. Momin. And also we could see on your last slides, maybe the picture of Dr. Muharfiza, Director of Polytechnic Engineering of Pertanian Indonesia. He's also here. He's also here. Dr. Muharfiza also here. Maybe Dr. Muharfiza, could you say hi?
Sorry, I am attending some ceremony in here.
Okay.
Just listening to you guys. Okay. Thank you very much. Hello, Momin. Assalamualaikum.
Alaikum salam.
Okay, actually,
I think I can turn on camera.
Yeah. Please turn on your camera. I also saw some of our colleague, Dr. Anisur Rahman. Oh, but maybe he also already left the chat. Okay, everyone. If you have any question, is anyone would like to ask directly? Don't be shy. Oh, Momin, Dr. Momin.
Yeah, I am.
Could you turn on your camera? No.
Yeah, sorry for that. Yeah, okay. It's working now.
Okay. Before maybe any other participant asking, I would like to ask some question.
Sure.
The previous vehicle that is it autonomous or not?
Which one? The robotics vehicle I showed?
The combine harvester.
Oh no, it's not.
Oh no,
It's a manual
it's
operated.
manual. Also,
Manual, yeah.
I see. Okay.
Because you
So-
know, in sugarcane harvesting operation is very complex. So they need to actually communicate with the tractor driver, semi-truck driver, and also the mill, because during sugarcane harvesting, the operation continuing 24 hours.
I see.
On the way, because from field to the mill is 45 miles away, so they always need to communicate. When the semi-truck will be here, like I heard from the farmer or grower, if the semi-truck late for 5 minutes, then maybe he has to more all the like 12 driver and labor, they need to sit idle. So
I see.
even one, they don't allow 1 minute. That's why
see.
it's not, it's still automated. And
see.
sugarcane is sugarcane, so a lot of complex thing there. So to communicate, yeah. Anyway,
I see. And also, you mentioned about the cost of the GPS and also RTK GPS, and
yeah,
you currently try to using low cost. How much it costs?
yeah. Because the first one we used, it is just for logging, like the normal GPS. It's not an RTK GPS. That's why we observed also sometimes more than 2 centimeter error. But the for guidance system, because we don't allow less maximum more than 1 centimeter error, so use the RTK GPS. But those are actually the Navier Spark one. You can, for both units, like base station and 2 units, you can buy $450.
Around
And the
400.
immediate one, yeah, is $500.
For the first GPS.
Yeah, both GPS
And
actually
how
for,
about okay.
we spent $1,000 for GPS, 2 GPS units. Yeah.
I see. And how about the low cost RTK GPS? I'm wondering how much does it cost?
Yeah, that one actually I was talking about. Those,
Oh.
I don't know, how can I show the slide here? Is it possible to go to the slide? Which slide you are now seeing?
No, you haven't shared the screen.
Oh, really? Okay. So this one, it cost us $550, and this one cost us like around 400.
I see.
Yeah, but they have all the modules and softwares available. So whether you want to run with BeagleBone Plug or Raspberry Pi, you can use it. So we actually use BeagleBone Plug using Linux here. So
And
you see this small system for data collecting.
And you could reach the accuracy also very good, right?
Yeah.
Yeah. So
Yeah.
I just wondering, compared to the SS sound, maybe
Yeah.
previously Dr. Slamet research about SS sound. How does it will compare?
I think I don't have any idea about that using sound, acoustic sound, but I think Dr. Widedo can answer this question because he did a lot of things using that technology, but we did not use any sound technology. So I don't have any idea.
Okay.
But when we compare this data, this result with our vision, machine vision data, our machine vision data actually was not working well. So because that because it's a 50 Logitech $2 camera, so the focus is not good. So we manually adjusted the focus, but still it's not working well. So
I see.
we stuck there.
Okay. Maybe Dr. Slamet, you have some comment or question?
Yes, I think this RTK GPS is very interesting. I think because with the price only $500 and the accuracy around maybe a few centimeters, this is almost like the professional RTK GPS. We also have another one in our campus. We have like we buy the very low quality. I think this is around $15,000 it costs, and the accuracy around 5 centimeters. And you see like 15,000
$15,000.
Yes.
Very expensive.
Yes, this
I know
the
it's
accuracy is
true.
quite good. Yes. For the normal RTK GPS, I think around 2,000 or 30,000, I think US dollar, I think. But we have the low, I think not so good, but the accuracy quite, I think okay, for around 5 centimeter, and even if we use for some static measurement, I think just a few millimeter, I think its accuracy is very high. But as Dr. Momin mentioned here, with the $500, I think it's quite promising. Especially we can also improve by using some sensor fusion, I think, and then we can get I think the much higher accuracy. And I think the price is very interesting because it's very difficult to add 2,000 20,000 or 15,000 US dollar to our system. I think no one will accept except for the very huge company, I think. And I think in Indonesia, it's also another challenge. I think not about the RTK. Of course, it's some opportunity to working with such low cost RTK system, but in Indonesia, the farming system is quite different with the US because we have only small size, and mainly I think in our campus, I think we are not working with some for some farming, but we are more focusing on the plantation, because in Indonesia, I think the big company on the plantation, and I think in terms of the infestation, I think they will, I think if they see some benefit, they will have some willingness to pay with some investment, and they have a lot of money, I think, for that. And I think it's more, I think more promising compared to we develop such system for the some rice farming or something others. Like I think plantation is good for Indonesia, I think, but the challenging is that we also try another new GPS system from the Japan. We working with some Japan company, but when we try in the plantation, we cannot get any signal for the GPS, so it's difficult. So I think if you have any idea, what is the good system maybe you can use for get some position in the plantation, for example, the oil palm, or maybe in some rubber, or maybe some forestry industry, because I think they also start to adopt some precision agriculture concept, and we are already developed, like for example, the some recommender system for the fertilizer, for especially for the plant oil palm plantation. We use some satellite image and also some aerial image using the drone, and we can get the recommendation for each plant actually. But the problem is how we apply such a dosage to the plant. So of course, there should be some automation there, but we cannot use the GPS. So this is the issue. So do you have any idea? Maybe this is another challenge for us in Indonesia, I think.
Yeah, I totally agree with you, Dr. Slamet, because if you use low-cost GPS, you should also, because the low-cost RTK GPS, you should need to think about how disruptive your base station versus your rover station. Because for us, we figure out that if we go more than 300 feet, the distance like between base and rover, we lost the signal. And also, I agreed with you, because in Indonesia, I don't know the farming, because you have a lot of palm tree is maybe even higher, longer, taller than the sugar cane. Or yeah, this might be an issue for creating the obstacle from the satellite to receive the satellite signal. So in that situation, you can try with this 2 GPS device. We can see is it working or not. Like I mentioned, the one we use for the yield map it will not work if you run your off-road machine below 6 km/h. So above 6 km/h, it has the capacity to communicate with the satellite. So of course, the environment condition, field condition, we need to think about. And another thing, not only in Indonesia and developing countries, I am now in Arkansas. The agriculture is totally different here compared to California. So here, actually, even last 5 years experience in my USA, if I don't come Arkansas, I don't understand the cultural practices for our agronomic practices even within the USA is different. Because in Arkansas is most of the farmers, they are small farm and they are minority farmers. They are not like California farmers. So they cannot afford like 20,000, 30,000 Trimble GPS device. So that's why actually I am now initiating my sugarcane field research to the soybean growers here. So I don't know whether it will work or not, but we just start. And future, actually, my target is the vision based. So that we don't need to depend on the satellite so much. So if we can develop a guidance system using low cost machine vision, I think that will be a more robust compared to the.
Okay.
Yeah, I shared the link of these 2 GPS. GPS. Yeah, if you want, you can order. If you need help, I can buy and send to you.
Okay, thank you. I think it's very interesting. I think I will try to use this to maybe 1 or 2 GPS. I think we will also start some automation in the farming, I think.
Yeah. We also in Brawijaya University, Universitas Brawijaya, will also try. Maybe.
Yeah.
Maybe we
even if you want, you can buy
future.
that robot. It will cost $1,500. I can send you that address.
Yeah,
so
yeah.
You can play and
yeah.
plug.
Actually, if you purchase from here, maybe the cost will be doubled or more than that. If we
let me know. I can help.
here.
So no worries.
Okay, thank you. And like Dr. Samad said, he bought 15,000 US dollar article GPS. It is almost the same cost with the vehicle itself. So so we need low cost.
We have an interesting experience. We published this study findings, 2 article GPS in computer and electronics in agriculture. But we went through a very hard time actually to publish it because we believe one of the reviewer was from industry. So he asked us very hard questions like, because, when you say low cost, because it's all related to the business. So then we said that because our target is to use this kind of technology for the developing countries, especially for researchers to progress in to do work in the precision ag area. So when we add these as to respond their comments, they actually agreed. Otherwise, in terms of business, actually they said no, it's not publishable. So
yeah, maybe the condition in Bangladesh and Indonesia almost the same, maybe.
Yeah.
Okay, is there any other question from the students? Kaulan, please unmute yourself first and introduce yourself.
Okay, thanks for the opportunity. My name is let me introduce myself. My name is Kaulan Sakila from Brawijaya University. I would like to ask you something. I see this GPS when integrated with agricultural vehicles can be used optimally when used in agricultural areas with geographically flat terrain conditions, like in California or Kansas that you saw in presentation before. However, is it useful when used in agricultural areas with extreme terrain, such as mountains or hills. And when used in extreme weather, can this tool accurately detect and measure land condition? As we can see, Indonesia has agricultural lands with extreme weather and terrain condition, also complicated natural factors. So I want to know how much potential it has. Thanks.
Yeah, this is very good question. Actually, I appreciate you to raise this question. Yeah, of course, the environment and the suboptimal weather conditions is an issue to operate your GPS, because we ran this GPS or more that robot in Illinois, but honestly speaking, we are not able to finish our experiment when the winter season started, because when we bring it to the field, our battery got drained out, or the GPS got stuck. So BeagleBone is not working because the temperature is almost freezing temperature. So the winter season is an issue for this kind of the devices. So we need to wait. So we wait for winter season, and then when the summer start, actually we start collecting data. So yeah, this is an important topic. So we need to handle the natural things. But for us, because it's all the BeagleBone block and everything is operated by a battery. So in the suboptimal weather conditions, actually they are not work. It's true.
How about the terrain? In mountain, the GPS
In
also
mountain,
can.
I did not try. Yeah, in GPS, maybe in agriculture here is on the mainland.
Flat
Maybe
area.
in California, we can try in the strawberry field or the, sorry, on the grape field. But in Midwest, actually, we did the experiment in Midwest US. So Midwest US is agricultural land is almost flat.
Okay. Is there any other question, Paulan?
No, there's no question. Thanks for the answer, sir.
Okay, thank you, Paulan and Dr. Momin. Also wondering, maybe could we also apply the Arctic GPS to robotics in the greenhouse?
This is
Maybe.
good. I think it's possible. Why not you give it shot? Is inside of greenhouse, it's more like not so many obstacles.
Yeah, because
So
the accuracy is in centimeter and millimeter.
Yeah, so yeah, give a shot.
Yeah, and maybe Dr. Slamet could compare with SSR.
And for your
in the
information,
greenhouse.
actually, for our data analysis, we did not use ArcGIS. We used QGIS.
Quantum GIS.
Because,
Quantum GIS.
QGIS,
Right?
because QGIS is a free.
Yeah.
And
quantum.
so you can play and plug a lot of things, like you can embed Python there. So whatever you want to do. So, and ArcGIS is an expensive software, so we use QGIS.
Yeah, good idea. Low cost and free software also.
Yeah.
Currently, I also moved to Python. Previously, I used MATLAB, so we are going to freeware.
And USA, even in USA, if you go some of the big university, actually they allow now QGIS, free software. Even they develop their own manual.
I see. Okay. Is there any other question? We still have around 20 minutes. We also have our colleague here from Unila, Dr. Diding, also joining us here. Maybe you know Dr. Diding, Dr. Momin?
Yeah, Dr. Shwandi, huh?
Yes.
Shwandi. Yeah, he actually, we joined at the same time, almost same time.
Yeah.
In our lab.
Dr. Diding, could you say hi? Oh, it's maybe busy.
Actually, I
Didi?
don't know. You guys know Dr. Ilo. I forgot his name. Today I met him actually through email. We are going to submit a project at USD and IFA for artificial intelligence and robotics. He's from Indonesia. I found that he graduated from Bogor Agriculture University.
Who is his name?
He recently joined as a faculty at Louisiana State University.
Oh, I don't know.
So let me share his name. So I went through his profile. He graduated from Bogor Agriculture University.
Oh,
maybe
it is.
Dr. Slamet student.
No, I
Maybe
think.
No,
not.
no.
Let me see where I lost it. Christopher
Okay.
Matthews Harris here. His name is, I don't know, he's Muslim or this is his name. You can check with him. Seti Yono
Yono.
3.
Maybe Dr. Slamet no.
Yeah, he graduated from Bogor. Then he did PhD in Nebraska, University of Nebraska Lincoln. Actually, before he joined at Louisiana State University, he worked at Erie in Philippines.
Oh, I see.
I see.
But he's from he graduated from Bogor Agriculture University.
I see. I see. Oh, there is a question in the chat box from Novia Luciana. He is now currently in Japan. Thank you, Professor Abdul Momin, for interesting presentation. My name is Novia. I'm curious about your method in GPS usage for sugarcane yield mapping. Have you ever using remote sensing, for example, through Landsat image for it? If we want to compare it, which one is better to be used? As far as I know, we're able to calculate biomass yield through NDVI, normalized different vegetation index. Thank you.
Yeah, very good question. Very good question. Actually, we also tried to compare our data with the NDVI, but unfortunately, the time we ran that our data, we tried to color. Also, I already have those data, those satellite imagery data to develop the NDVI things, but unfortunately, that particular time, the weather was not good, and that because Edgard is a little bit remote area, the sugarcane farms, so we did not get the actual good quality satellite image that time. Because also maybe because the experiment was done in Thanksgiving weekend, so it's a throughout the US they enjoyed this Thanksgiving week. So I don't know. We had some difficulties because that is very good point. We also tried to include that portion into our research because satellite image is readily available data. You just need to download and play and plug. But unfortunately, our data that particular time, like November 15 to November 25, those 10 days, we did not have good quality data from satellite image. So that's why it's we are lacking for comparing the satellite data versus the GPS data. But of course, NDVI is a very good param variable. I think someone shared the Setu owner's profile.
Yeah. Okay, thank you. Yes, like also Dr. Slamet previously mentioned that the IPB also developed some software based on the satellite image called Palm, maybe, if I'm not mistaken, to assess for mapping of the oil palm plantation. Yeah. I think maybe we could compare also later with different method. Thank you, Novia and Dr. Momin. And also, actually, we have also here our colleague from Malaysia, Dr. Mahira, if you remember, maybe.
Oh, yeah.
Dr. Mahira.
Yeah, hi.
Could you say hi?
Hi.
How are you, Mahira?
Good,
Mahira
thank
San.
you. How are you? A good
Yeah, nice to
presentation,
hear you
Dr.
after a long time.
Yeah, good presentation, Dr. Momin.
Yeah, thank you. For your information, recently I had talked with Dr. Jul Ilham. You remember Jul Ilham?
Sorry?
Dr. Jul Ilham.
Yeah, yeah.
Yeah, I had talked with him last weekend actually.
I see.
Maybe later I will invite many colleagues from outside of Indonesia to give guest lecture here, including Dr. Mahira, maybe.
Yeah, sure. Yeah, feel free to include me and let me know. So
Of course, in the future, I hope we could do collaboration. Maybe. Also, I would like to ask: is there any possibility for example, for our staff to continue PhD there? Is there any scholarship or chance?
very good question. Actually, as I mentioned, that agricultural engineering department is a fairly new department here. So they recruited three actually. First, I am handling the farm machinery side. One of my colleague from Washington State University, he joined here. He is handling the like mechanical design, this kind of thing. Another colleague is irrigation. So we are now trying to actually right now we are trying to develop the curriculum for our students, redesign or revising the curriculums, as well as right now we don't have any opportunity, but from next fall I believe we are going to recruit master's student, especially from outside. But anyway, if any of the students are interested, so if they contact, so I can connect them with the program coordinator. He's a very good friend of mine. So yeah, and for also I am trying to develop a center of excellence in one of our farm based on precision ag technology or emerging technologies. Obviously there in future, hopefully from next year, we will have a lot of opportunities. And also I'm trying maybe in future to develop a student exchange relationship. There are opportunities for this. So yeah, since we just
we are looking forward for that chance.
So yeah, there is of course there is possibility.
Okay, Dr. Mahira, what is your research now? Is it related with Momin, Dr. Momin? Your research now?
Now my research is about the image processing for rice and also for coffee grading.
I see. So maybe after this, Dr. Momin also will develop some machine vision also.
Yeah, how about your rice paper?
I'm also looking forward for that rice paper.
Hopefully soon.
Okay. Okay. Any other participant? Is there any question? We also have Dr. Muharfiza here, the new currently appointed Director of Polytechnic Engineering of Agriculture Indonesia.
Great.
You are still mute. You are still mute, Dr. Muharfiza.
So, Momin Sang, we met around 2015, I guess, in Bali.
Oh, really?
The last slide of the presentation, there is a picture of Dr. Muharfiza.
Yeah, my pictures on your last slides.
Yeah.
The red one, the red shirt, I think.
This one?
Yeah.
Oh,
yeah.
No. Yeah, that one.
This?
So, yeah.
Oh, I think I know you very well.
You should know me, no? So now I'm working in some polytechnic vocational school actually in Indonesia. So this school belongs to the Ministry of Agriculture. So I am a director in here. maybe 1 month ago. So I'm still a newbie to be a director actually. So
Oh,
I have
congratulations.
thank you. I have a plan maybe to make some collaboration with Dimasang and also with Diding Suhandisang and also with Mr. Slamansang. So in the future, we would like to expand our collaboration until the Southeast Asia. Maybe I will target to Bangladesh also.
Sure.
Hopefully, the COVID will be controlled and every place is already open. So I will be go to your place one day.
Sure. Yeah, please feel free. As I said, right now I don't have any opportunity because I joined. This is my 3 months and busy with the class.
Yeah.
So hopefully next year, I am looking for opportunities, collecting some money. So
Yeah,
hopefully
okay.
next year. Yeah,
Inshallah.
meanwhile, if you think we can submit something joint proposal, let me know.
Yeah, okay.
I'm always open.
Please take me also, Dr. Mahardika.
Yeah, sure. I need you guys to develop my laboratory facilities.
Thank you, Padima,
Okay.
for the opportunity to talk with Mr. Momin. This morning I have some ceremonial, like,
Okay.
with the students.
So also, we also would like to congratulate Dr. Mahardika for the appointment as director
Thank
of
you.
PEPI.
Thank you very
Okay.
much.
Okay. Is there any question from the participants? Other participants? Actually, we have also Dr. Iris here from previously also from Kyoto University, and also several other colleagues. Yeah, and also
So,
yeah.
if no question, I think I have one question for Dr. Momin.
Okay, please, Dr. Saman.
Okay, so I think you have a lot of experience with some universities in the US, right? And then my question is about our education, especially in the agricultural engineering, because I think I don't know in US, but in Indonesia, I think compared to other study program like engineering, for example, mechanical or maybe petroleum or maybe even others engineering program study, I think many students, I think that what is agricultural engineering and what is the future when we take this study program. So what is your opinion and also maybe your experience related to like the not so many young generation, I think, interested with the agriculture or maybe agricultural engineering, and maybe they see that this is something no future in terms of the career development. What is your opinion about this future? I think you have so many students here, I think. So I think I would like to know about your opinion with your experience with the many universities in the US. What about the interest of the maybe some high school student to enter the agricultural engineering field, and also about the career opportunity in our field. Thank you very much.
If you don't allow me another 5 minutes, I will just exactly the same question. I would like to share your presentation because just last Thursday, I gave a similar kind of presentation to the STEM students here at University of Arkansas. So they were asking me, actually our dean was asking me the same question. What is the future of an engineer? What kind of job, career opportunities? So just let me share my presentation that I did last Thursday. That will answer your question. You know, if you go to the United States Bureau of Labor Statistics website, and you will hit the outlook of agricultural engineer, you will be surprised to see the salary of an agricultural engineer. Even just immediately after completion of bachelor, they are getting $80,000 US, the median salary. So I was also surprised. And in USA, you know, the possibility, opportunities of ag engineering is growing up because now people are thinking conservation agriculture. Now people are thinking soil conservationist. So also precision ag, also smart agriculture. So who will deal that? That's why I'm saying the future of agriculture is depend on the next generation problem solvers. That means the agricultural engineer. But what we need to know to our curriculum, we need to just revise something, like to see we have some knowledge of electronics, knowledge of computer programming, like hands-on knowledge, like, oh, you just learn the C++. No, just how to run your MATLAB, what kind of like thing you want to develop your future this area. So for that particular area, what kind of hands-on things you need, so focus on that. Because if I see our curricula in Back to Bangladesh, like we are around 140 credit hour we earn for our bachelors, but we learn like computer programming. So actually those in general thing is not necessary, but we need more applied things. But let me share one slide for the students to give them some idea for agricultural engineers. So where it is. Can you see?
Yes, we can see.
Okay, so now so what I said, like if you go to the Iowa State University website, sorry, ag engineering website, you will find, like if you want to solve the problem, if you use try to learn hands-on application or design implementation, then if you want to good at mathematics and understand how things are we are creating, developing, or interested in environment, biological science, agriculture, and to help future save food for future generations, definitely you should consider the ag engineering major in your college. So in USA, what kind of jobs and agricultural engineering will get? Because as you know, agricultural engineers, they design, develop, and create the systems, machines. So there they have a lot of job opportunities. For example, they can work in leading agricultural farms and government services like in USDA, federal government, state government, consulting agencies, and some other industries, business, and sales personnel in the company, and also directly can work with the farmers. But if you see here, look, this is the May 2020 data from US Bureau of Labor Statistics. Where an agricultural engineer just after graduation without any master's degree, if he work in the federal government, then annually he can earn 92,000 US dollars. But of course, the salary for an agricultural engineer working as a teacher or professor is always low. You see around 60,000. It's true. Teachers, yeah. but but engineering services, so there are opportunities. So we need to just enhance our knowledge beyond traditional ag engineering to know some hands-on applications. Then we can fight with others. Yeah, I believe it's true. It's competitive nowadays. Electrical engineers, they are also working for as an agriculture engineer, mechanical engineers. But we need to grow up ourselves to learn the hands-on things, and then we can compete. And there is opportunity. So don't worry about what we will do as an agriculture. After complete agri engineer, come to the USA, do the masters, and go from there.
Yeah. Very interesting. We hope that the salary also in Indonesia also similar with the US. But I think it is promising, but maybe we need to promote more the agriculture engineering field to the high school students, so they will know better about agriculture
Yeah,
engineering.
do some demonstration. Like recently, we showed a demonstration like the video processing.
Mhm. Yes, very nice discussion today. Is there any other question?
The object.
Sorry, I'm sorry.
Yeah, do some video demonstration, like the video processing. Do some interesting thing with the high school graduates to motivate them to come to the ag engineering. So this is actually one of the service requirement here in USA to be a university professor. You need to do this kind of thing as well.
Okay, thank you very much for
Thank
the
you.
sharing, Dr. Momin. I think we have a lot of new knowledge today, and it is a very fruitful discussion. We hope that we could continue our collaboration in the future, also with all of our colleagues that joining us here. Thank you very much. I think time is up for today's session. We hope that we could meet again on the other chance. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Good
Yeah, thank you everyone.
good morning and good evening
yeah.
in US.
Thank you.
Okay, good
Yeah.
night, Dr. Momin.
Thank you, and happy Friday, everyone.
Okay, bye-bye. Thank you.
Bye-bye.
Oke, terima kasih Pak Slamet, Pak Bangmu, Pak Ari.